Bismillahirrahmanirrahim. Assalamu alaikum and very warm welcome to my channel. Today we will learn about the optical density, how to measure the optical density from spectrophotometer data or the absorbance data. First of all, you should know what is the formula of optical density. Optical density is equal to alpha into L. D optical is optical density and alpha is absorption coefficient while L is thickness of the cuvette which you use. This is normally 1 centimeter. The thickness is normally 1 centimeter. While to find out alpha or absorption coefficient, we have the formula that alpha is equal to 2.303 into absorbance divided by the thickness. This is, for example, we have I have some data, some absorbance data, the wavelength and the absorbance data. So this is uh, a sample data from which we will calculate the absorption coefficient, and then absorption we would first calculate the absorption coefficient, and then we will find out the optical density at different wavelengths. So let's go to this. So over here is our absorption coefficient. Okay, the formula is the absorption coefficient formula is 2.303 multiplied by absorbance divided by thickness. So let's write thickness over here. Thickness is 1 centimeter. So let's write the formula again is equal to 2.303 multiplied by absorbance and divided by thickness. So we will log this thickness to have the same reading below. So just double click over here and the formula will be copied all the way till 200 nanometer. Okay, so this is wavelength. Wavelength is in nanometer. Okay, so this is our wavelength. This is our absorbance. Absorbance value is arbitrary unit. So we'll write it as A and the coefficient. Now, as we calculated the alpha, we will calculate the optical density. Optical OD, optical density. Optical density is equal to, as we know that in this formula, optical density is equal to A into L. So what we will do, we will write is equal to, this is our A multiplied by thickness is 1. We write it again is equal to this multiplied by thickness. Okay, and double click this. Sorry, this thickness. This thickness will be locked. Just putting the dollar sign before and after the column, it will lock that column. And this is the optical density of all this. Now you can put this into a graph in origin. Let's copy this data. Let's copy this and this, and we'll put this into the origin. We'll remove these two. We'll remove these two columns, and we have wavelength and optical density over here. Now just simply make a line chart, and this will give you the optical density of your sample at different wavelengths. So in this way, you can find out the optical density of your sample. You can play with this. You can increase the width. Okay, you can increase the width and so on. So this is the optical density of your the sample at different wavelengths. For example, we want to know the optical density at 600 nanometer. So this is 600 nanometer. The optical density is 1.68. We want to know the optical density at 500 nanometer. So 0.64 the optical density at this nanometer. So hopefully now you have learned about how to calculate the optical density and how to plot it against different wavelengths. So the formula for optical density is this alpha into L, where alpha is absorption coefficient, L, A is the absorbance, and L is the thickness, which is 1 nanometer. And put this formula, first of all, calculate the absorption coefficient. First of all, calculate the absorption coefficient by multiplying absorbance with 2.303 and divided it with the cubic thickness. This will give you absorption coefficient, and then optical density is the absorption coefficient multiplied by thickness. This will give you the optical density. Then plot these two into in Excel and get this formula. Thank you very much. आपको समझ आ गई होगी. Hopefully you understand how to calculate the optical density from the observer's data of spectrophotometer, and then plot it against different uh, then plot the optical density against different wavelengths at different wavelengths. Don't forget to like, comment, and subscribe. If you need any special lecture on a special topic, please comment on in the comment section below, and I will try my best to upload those lectures for you. Thank you. Allah Hafiz.